Hey everyone, today we're going to look at finding the zeros of a polynomial, and I have one listed here. Anytime it says find all the zeros of a polynomial, there's a couple things I go through because there may be some nice numbers that are zeros, but there also may be some irrational that include roots, or there may also be some complex numbers that are zeros, and so just go through a process of trying to find the easiest ones I can first, and then doing the harder ones later. And so what I'm going to do first is just to graph this to see, are there any zeros that are nice rational numbers? So things like maybe a 2 or a 3, maybe even like a 5 halves or something like that. But just something not involving complex or roots. So I'm going to go to the graph. So we'll take a look at Desmos real quick, see what I can get there. And I have the graph pulled up here. I'm going to switch these. Maybe I'll just leave it in this order. So here's the equation, right? X to the fourth minus 4x cubed minus 7x squared plus 74x minus 104. If you weren't using a graph, probably the way you would start would take the factors of 104, right? List all your possible factors over factors of 1, which go with your x to the fourth, and then just start testing them, right? So that would be kind of the old by hand method that you might use. But taking a look at the graph, it looks like right here we do have a negative 4, 0, right, as 0 and 2, 0 also. So this means that I would have negative 4 is 0 and 2. So I'm going to go ahead and write these right here. So some zeros that we have are negative 4 and 2. And there should be a total of 4, right? So we looked in the last video at just the theorem that said if you count all the zeros, including complex zeros, then it should equal the degree, right? So since this is degree 4, we should have 4 zeros total. And if you zoom out on the graph a bit, you can see there's really only going to be 2. There's kind of a wiggle in there. But there's only 2 zeros that cross the x-axis. So that means only 2 real zeros right there at the 4, negative 4, and 2. So those 2 points right there. And then the other 2 are going to be complex. So we should expect some complex zeros on this one. So I'm going to go ahead. We don't really need the graph anymore for this. So I'm going to go ahead and hide the graph after that point. And we'll go through and just take a look at what do I do with these zeros to find the other ones. And what I'm going to do is some synthetic division, right? So if these are the zeros, I'm going to also list here my factors. Currently, right, would be x plus 4 times x minus 2. And again, there would be 2 more factors, right? If I had x minus whatever complex number made a 0 for this one, and the other x minus the other complex number, that would be the 0 for this one. So we'll go through and find what those are. So I'm going to do some synthetic division. So I'm going to write down, right, I'm going to start with the negative 4. You could start with the 2. That would also be fine. And I'm going to write down, right, the coefficients of this polynomial. So we got a 1, negative 4, negative 7, 74, and negative 104. So this is back when we talked about synthetic division, which I expect you had seen. Maybe it'll be a little rusty, but it should just be a quick refresher here. So we'll bring down the 1. Negative 4 times 1, right? Negative 4. Add, we get negative 8. Negative 4 times negative 8. That'll be positive, 32. We'll add those, and that will be, let's see, a negative or positive 25. Multiply negative 4 times 25. That'll be negative 100. We'll add those. That'll be a negative 26. And then negative 4 times 26 is 104. And when I add those, I should get 0. If you know something's a 0 and you didn't get 0 at the end here for your remainder, you need to go back and check your work, because it should come out to 0 if this is actually a 0 of that polynomial. And this means, right, what I have now is x plus 4 times x cubed minus 8x squared plus 25x minus 26. So that would be the other factor I would write here if I were trying to factor this out. I'm not going to do that just yet because we know we have this other factor, right, of 2, and I would like to take out the 2. So let's go and do another synthetic division. I might actually change colors here. Let's do purple with the 2. All right. So we'll go and do that one as well. And I'm going to do the same thing, right, synthetic division. So bring down the 1, and then we got 2 times 1 is 2. Add. Negative 8 and 2 is negative 6. 2 times negative 6, that'll be a negative 12. 25 minus 12, that's a 13. And then 2 times 13, that's going to be 26. And when I add those, I get 0. Again, this part over here, that was the remainder, so we're not using that part anymore after this point. If I knew another 0, right, I could take that one out as well, kind of be left with the last factor, but these are the only 2 I know. So for right now, right, this is an x squared minus 6x plus 13. And I'll go ahead and write that up here. So my factors so far, right, are x to the 4th times x minus 2, and then this x squared minus 6x plus 13. All right. If we multiplied all that out, we should get back to that original expanded polynomial. So this factor right here, this one in purple, this is the one that's going to help me find my extra zeros. So if that is 0, then we can find our other zeros. And solving this is a lot easier with, say, quadratic formula, because I know I can just plug in the numbers and go through solving that. So we'll go through kind of quadratic formula on this guy, see what we get. So we're trying to solve this, right? X squared minus 6x plus 13 equals 0. Quadratic formula says, I'll go and write it over here, right? X would be this negative b plus or minus that square root of b squared minus 4ac, right? All over 2a. So I'm going to go and fill in the blanks, right? So on this one, we would say x is this negative b, in this case 6. So what I like to do is if I have negative of a negative, I just change that right away to a positive. So this is positive 6, right? And then plus or minus square root. We got the b squared, so this negative 6 squared would be a 36. And then minus 4 times negative 6 times 13. All right, I'll probably need a calculator to figure those guys out. And then I'll divide by 2a. A in this case is just the 1. So, and actually, I can see I messed up on this part right here. That should just be a 1, right? 4ac, not 4bc. So 2 times 1 on the bottom. All right. And then we'll go through, multiply, add, all that for these guys. See what we get. So let's see. So I'm going to get here x equals 6 plus or minus. And then the inside of this root, the 36 minus 4 times 13, that just comes out to negative 16. So we'll put root negative 16. And then divided by 2. And this you will want to simplify a little bit as much as you can. So the square root of negative 16, right? Square root of negative means we're going to have an I. Square root of 16 is just 4. Right? So I could say this is x is 6 plus or minus 4i all over 2. And then we'll divide the 2 into each of those. So I get x is 2 into 6 is 3. And 2 into the 4 is 2, so 3 plus or minus 2i. So that's it. So these would be my other 2 zeros that I want. And You may have expected this, right? Conjugate pairs, we talked about that theorem last time. If you do have complex zeros, they will occur in conjugate pairs if your original polynomial didn't have complex numbers in it. So since our original polynomial just had regular numbers, no real numbers, no complex numbers, we are going to expect there's going to be some conjugate pairs here at the end. So let's go ahead and put those, I'll just list those here with the other zeros. So we had a 3 plus 2i and a 3 minus 2i. All right, so these are the zeros that I'm looking for. One other thing that I'll mention, so this would be pretty much done for what they asked us before, which was to find all the zeros. Sometimes they may also ask you to factor, and in this case, right, it depends on kind of how they word it. If they want the factors over the reals, then it would be something like this that I already wrote down. So this would be what we call factoring over the real numbers, meaning I don't want any complex numbers in my factors, and since factoring this would give me complex numbers, then I'm just going to stop at that point. If we want to factor over the complex numbers, then it would look something like this. So the factors would be the x plus 4, same as before, the x minus 2, and now x minus each of these complex zeros. So we get an x minus 3 plus 2i. That negative will distribute, so we get something like an x minus 3 minus 2i on there. And x minus this other 0, again the negative will distribute, and we'll get x minus 3 minus the negative 2i would be a plus 2i. So something like that. And this would be what we call factoring over the complex numbers. So factoring over complex numbers. On these, the real thing to note is, right, what you have. Whether or not you have real zeros or complex zeros, you can always use a graph to try to find the real ones. Sometimes they're nice, sometimes they're not, so that might depend on how well this next part goes. So if you can find some nice real ones, these rational zeros, then you can go ahead and just divide those out with some synthetic division to get those two factors pulled out, and whatever's left generally after that, we'll try quadratic formula or something like that. So that's typically how these go. Whether this is a complex zero or a zero that has roots that I'm not sure what it is. First we divide out the rational zeros, and then we work with what's left, usually trying to do quadratic formula on the leftover part. So that is kind of it. Synthetic division, right, you can also do kind of back-to-back if you have more than one. Sometimes if it's a cubic, you might only have one of those that you'll take out, and then try quadratic formula after that. But go ahead and use the graph, right? Pull as many real, right, zeros as you can identify off of that thing, and then work with what's left to find the other ones. So that's kind of how that goes. That'll do it for this video, and we will see you on the next one.